All right. Tangent line of a function f(x) at x equals a can give you an approximate value for f of x for points close to a. Now, the idea here, we'll zoom in a bit here, is if we have, let's say, this point here, and we draw a tangent line to that point, we can use that tangent line to approximate for values that are relatively close to the point. Now, as you notice, the further we get away from that point of intersection, the less accurate we're going to be. So you want, again, we only do this for points that are relatively close. Right? Now, if you look at all these points, every point on here on the tangent line, is that going to be an overestimate or an underestimate of the actual equation? Being that the tangent line is below the function, it's probably going to be an underestimate. Same thing if it was concave down. Again, we pick a point, draw a tangent line. Every value above that line is going to be over, so this is going to be an overestimate. Now, being that we haven't talked about how to determine when a function is concave up or concave down, we'll do that in chapter 5. You are going to be given that the function is concave up or concave down. Right. So, step 1, f is concave up. So we do know it's concave up on the domain with f of 4 equals 5 and f prime of 4 equal to 3. Okay. What is the estimate for f equals 3.8 using the local linear approximation for x at 4? Now, what that means is we first do have to create the equation, and since we are given the x, y coordinate and the slope y minus 5 is equal to 3 times x minus 4 is our equation. From there, we just plug in 3.8 in for x. So, y minus 5 equals 3 times, now 3.8 minus 4 is going to be a negative 0.2. So y minus 5 equals negative 0.6, and if we add 5 over, we get y equals 4.4. Now, is this an underestimate or overestimate? And we said if it's concave up, it is always going to be a what? Underestimate, right? So the reason for this, it is an, as I just said, underestimate. It is an underestimate because f of x is concave up at x equals 4. As comparatively speaking to what we did the past few days, this should be pretty easy. So function f equals 5x minus 2x cubed minus 2, which is concave down, at x equals 1. Find the tangent of the line at x equals 1, which means we need to find the equation. Now, first thing, we do need a coordinate. So we know x is 1. Okay, what is y? Well, if I plug in 1, we have 5 minus 2 minus 2, which is equal to 5 minus 4, which is 1. So if you plug in 1, you get 1. Next, we need to find the slope, and the slope, again, is the derivative at 1. So f prime of x would be 5 minus 6x squared. And then f prime of 1 would be 5 minus 6, which is negative 1. So my tangent line is y minus 1 equals negative 1 times x minus 1. What is the estimate for f at 1.1? Well, plug in 1.1 here. Y minus 1 equals negative 1 times 1.1 minus 1, which gives you y minus 1 equals negative 0.1. Add 1 over, I get y equals 0.9. Again, because we know this is concave down, this is going to be an overestimate. Because f of x is concave down at x equals 1. Now, this last one looks a little bit complex, but the nice thing is this is the derivative of the function, and they give you your x, y, so you have a coordinate 2, 0 right here. So if they give you the derivative, all they want you to do is plug in the values for x and y. So that means that we have the slope is equal to e, since y is 0, so 0, times 2, x is 2, so 2 squared minus 5 times 2. That gives you 1 times 8 minus 10, so negative 2. So my equation would be y minus 0, or just y, equals negative 2 times x minus 2. Now for the estimate, plugging in 2.2, so y equals negative 2 times 2.2 minus 2. Well, that gives you negative 2 times 0.2, which is negative 0.4. Now, that is actually it for the notes. Easy day today. Any questions on the homework of 4.4, 4.5? I did finally post those videos. So for the 4.4, 4.5, if you missed those. Well, 4.4 and 5 are
Essentially the same, like good combination.
yeah, they really do. Now 4.4 you don't solve, 4.5 you do.
I read them about it.